Hi, my name is Huizheng. My ID number is 2301053. In this video, I will be demonstrating my project, Smart Environment Monitoring System. This system is based on the Raspberry Pi simulation environment and is capable of the following functions: real-time monitoring of temperature, humidity, and air pressure, real-time displays on the web interface. Users can customize the threshold, automatic auto generation, data analysis and forecasting, basic security and error handling. I will now demonstrate the system's implementation and how it works, step by step. This is the structure of the project, which includes the sensor backend and frontend. First, I will outline the system's overall data flow. Emulator, sensor, backend, database, frontend. This system collects environment data every 3 seconds and sends it to the backend for storage. First, open the intermediate. Now, we open the emulator. At this moment, the intermediate is continuous outputting data. As you can see, the sensor program is continuously reading data from the emulator and sending it to the backend via an HTTP post request, and it can be displayed in the browser server link. Here you can see that the data has been successfully saved to the database, including temperature, humidity, pressure, timestamps. This indicates that the data collection and storage functions have been completed. Next, I will demonstrate the web interface. The front end automatically sends a request to the back end every 3 seconds and refreshes this page. You can see that the page data updates automatically without the need to refresh the page, which meets the requirement for real-time update in the assignment. This is the line chart. Below is a chart showing history temperature data, which clearly illustrates temperature trends. Next, we will demonstrate the warning system. This system will automatically trigger an alarm when the data exceeds the threshold. The default threads are these here. This is the begin. We can set the temperature to 45. And you can see the system that is with its temperature exceeds 40 automatically generates a warning and displays it on the page. This is warning. Now we change the temperature max to 30. We can currently use the user-defined threshold, and you can see when we change the temperature to 31. The warning is already consistent. Next, we will demonstrate the data analyze feature. The system analyzes the most recent two data points, including animal indication, trend analysis, and forecasting. We change the temperature 20 to 30. Change to 30. We can see this is a sudden spike, indicating that the system is capable of identifying sudden changes in temperature. Now we change the temperature to 20, 22, 24, 27, and 30. We should change it more sharply. So you can see this is an uptrend, indicating that the trend analysis function is working correctly. Now we change the temperature to 34, 37, and you can see may exceed max threshold soon, suggesting that the predictive capability has been achieved. Now, I'm sharpening down the back end to simulate a network error. There is show can't connect to the back end server. And you can be seen the system didn't crash but instead display an error message, indicating that its process basic error handling capabilities. Now we recover this. Yeah, we can see there. We change the mean temperature to 40 and the max temperature to 10. You can see the temperature minimum must be less than the maximum. This is an invalid input. This system is capable of blocking unauthorized input, while the backend employee practices errors to prevent secure injection, thereby ensuring the system's security. Next, I will briefly explain how the system's key factors are implemented in the code, correcting the require 1 to 7 in the assignment. First, see here. Here, the Sense HTA emulator is used to retrieve temperature, humidity, and barometric pressure data. Next, you see here. Oh, here. The data is then sent to the Flask backend via an HTTP post request to enable data upload and storage. Next, we open JavaScript. Here, the front end uses set interval to send a request to the backend every 3 seconds, thereby enabling real-time updates. Next, yeah, this. The back retrieve data from the backend using fetch and update the page display. Next is recovery warning system. We can see here. The backend generates a warning message by comparing the current date with a threshold and returns it to the frontend for display. Next, require for security. We can see this. Parametric requeries are used here to prevent circle injection attacks, and the system also validates user input to ensure data security. Next, requirements file data analyze. Here. Here we calculate the temperature trends and use the changes to determine whether it has been a sudden change, whether the trend is rising or falling, whether the value is likely to exceed the threshold. Besides, question requirement 6, error handling. Yeah, here. We can use the try and except. Through try except blocks to catch network errors, ensuring that the system doesn't crash and that users can notify of the problem. At last, requirement 7, code quality. Here, this system employs a modular architecture, sender data acquisitions, back-end data processing, front-end user interface. The code is clear in name and well structured, making it easy to maintain and extend. The above outlines how each of the system features is implemented at the code level, corresponding to requirement 1 to 7 of the assignment. At last, to summarize the functional implements by the system, real-time data collection and storage, dynamic web display, customizable threshold and dot system, temperature analysis and forecasting, error handling, and basic security measures. The system operates reliable and meets all optional requirements. Thank you for watching.